All right, this video is going to go over 5.3b. It's basically the same as 5.3a. You're going to be solving systems that have 3 variables. So each system has 3 letters, x, y, z. You need to find out each letter, x equals, y equals, z equals. So the way you do this is you need to pick a letter to eliminate twice. So like when I look at this problem, the first thing I see is this right here. So if I add, I'm going to number these equations, equation 1, equation 2, and equation 3. So if I do equation 2 plus equation 3, it would look like this. So I'm going to add these equations together. Z is going to eliminate, so it's going to make 6x minus 4y equals 24. Now I have to eliminate z again. So when I'm looking at this, I'm looking at this right here. And if this said minus 2z, then it would work. So I'm going to times equation 1 by 2 so that it will say minus 2z. Then I'm going to add it to equation 2. So it's going to look like this. I'm distributing a 2 to this entire top equation. Then equation 2 is the same. Now if I add these together, z cancels, which is what I wanted. All right, now that I have z canceled twice, I'm going to have to use these 2 equations to eliminate another letter. So let's go ahead and look at them vertically. All right. So just looking at this, it's not going to be very nice to us. You're going to have to scale both of these equations. So I'm looking right here and thinking if this said minus 12y and this said plus 12y, then they would eliminate, right? So I'm going to times the top equation by 3 and the bottom equation by 4. So it's going to look like this. See, now when I add them together, the y's will eliminate, which is what I wanted. Divide by 46. You get x equals 2. Once you know that, you can plug x into like this red equation right here. Really, any of these equations would work, but this red one or the blue one's probably the easiest. So it'd look like this. So now I know what y is just from solving that equation. So once I know what x is and what y is, then I go back to my original equations. It doesn't matter which one you choose. I'm just going to choose this last one. Now I know what z is. So when you write your answer, it's an x, y, z coordinate. So it'd be 2, -3, 1, x, y, z. All right, now looking at the second equation, I'm looking at the z's here, and like these would eliminate pretty easily, but then I would have to scale probably equation 2 to make it say plus 2z to eliminate again. So you could eliminate z twice, but that's probably not what I'm going to do. I'm looking at the y's. I've got a plus y, a minus y, and a minus y. This is going to work out nicely for me. So, for example, to eliminate y the first time, I would do number the equations, 1, 2, 3. If I do equation 1, plus equation 2, it would look like this. So the y's would eliminate. Now, what happens in this one? Luckily for me, the z's eliminate as well. So you end up with 3x equals 6. So you divide by 3 and you get x equals 2. This is rare that you get a variable this early. Now, it's still not going to be enough information for me though, because like if I knew x was 2, well, I still don't know what y and z are, so I still can't solve this equation. So I'm going to have to do another one. I'm going to go look to eliminate y again. So now I'm looking at this plus y and this minus y. So if I do equation 1 plus equation 3, the letter y would get eliminated again. So let's do that. It'd look like this. Add them together, the y's eliminate, so you end up with 2x minus 3z equals 7. Well, this is where having this x value already is going to come in handy, because it's just going to get plugged in there. And now you know what z is, -1, just from solving that equation. And so now that I know x and I know z, I'm just going to plug both of these things into any of these equations. We'll use the top one, but it doesn't matter. So it'd look like this. Once I know what x, y, and z are, I write my answer as an x, y, z coordinate. All right, this last one, when I look at it, the thing that's jumping out at me are the y's. Because like if I did equation 2 plus equation 3, the y's would cancel there. And then if I did equation 1 times 2, and then add it to equation 2, the y's would cancel as well. So those are going to be the two moves that I'm going to make. I'm going to start by doing number your equations. 2 and 3 added together would eliminate the letter y. So I'm going to do equation 2 plus equation 3. So it's going to look like this. Let me fix that. All right, so when you add these together, the letter y eliminates. So I get 6x plus 5z equals 4. All right, now the second one that you're going to have to do would be like if this said 2y and I added it with equation 2, the y's would cancel. So I need to do equation 1 times 2, then add it to equation 2. So I'm going to scale this top equation by 2, like this. So it's going to look like this. That's the top equation when I scaled it. Then the second equation doesn't change. Now if I add these together, the y's cancel, which is what I wanted. You get 10x plus 5z equals 0. So now I can take these equations and go vertical with them. So 6x plus 5z equals 4, and 10x plus 5z equals 0. All right. Now that I have this, I'm looking to eliminate another letter. So I'm looking at the z's here. And I'm thinking, okay, if one of these just said minus 5z, it would eliminate nicely, right? So I'm going to scale. It doesn't matter which one you choose. I'm going to choose the top one to scale by -1, because then it would say -6x minus 5z equals -4, and my bottom equation wouldn't change. And I would be set to eliminate the letter z and end up with 4x equals -4. Divide by 4. Now I know x is -1. Now plug x equals -1 into either the red or the blue equation. I'll go with red, so it'd look like this. Now that I know what x is and what z is, I can use any of these original equations. I'll just use the bottom one. Now I know what y is, and I write my answer as an x, y, z coordinate. Okay, and there's 3 more examples for you for solving systems when there's 3 variables. Hope this video helped.